In this video, we're going to go over section 5.4 and 5.5 from our textbook, which goes over properties of power and root functions and how to solve them. So we'll start off with this here, a function f, which is given by this here, f of x is equal to x to some power b, where b is a constant, is called a power function. Now, if b is equal to 1 over n here, for some integer that's greater than or equal to 2, then f is called a root function, and it's given by this here. Another way to write this guy is with this radical symbol here, and we say that this is the nth root of x. Now, if f of x is equal to this guy here, where this fraction, p over q, is in lowest terms, if q is odd, the domain is going to be all real numbers, and if q is even, the domain is going to be all negative real numbers. So let's look at these examples here. We want to apply the properties of power and root functions to simplify the expressions here. So first, looking at this one, we have the third root of negative 64 here. So we're looking at a function of this form. So what we're looking for is a number that when it's cubed, we get negative 64. Notice that negative 4 times negative 4 times negative 4 gives us 16 times negative 4, so we get negative 64. Okay. So inside these parentheses here, this tells us that the third root of negative 64 is going to be negative 4. So inside our parentheses, we have negative 4, and we still have that this is to the fourth power. Now doing negative 4 to the fourth power is going to be this negative 4 cubed here times another negative 4. So we can just do this as a shortcut here. Multiplying these guys, we get 256, so this is going to be 256. Alright, let's look at the next one here. We have 9 to the power 3 over 2. So looking back at this guy here, we have 9 to some power. So we can rewrite this as 9 to the 1/2 power cubed, right? When we do this, we're just going to be multiplying these exponents here. And in this case, we can rewrite this as the square root of 9 cubed, just by this property here. Alright, then the square root of 9 is going to be 3, because 3 times 3 is 9, so we'll get 3 cubed, which is equal to 27. And then something to note here, whenever we have the square root, we tend to just, we don't write the 2 here. When we're looking at the cube root or anything above 2, we have that number here, but when we're looking at the square root, we don't need to put anything there. So if we just see this radical symbol with no number there, we automatically assume we're looking at the square root. Alright, let's look at part C here. We have 32 to the 3/5 power. So again, we can rewrite this as 32 to the 1/5 power cubed. Because when we multiply these guys, we would get 3 over 5. So we want to find a number that when we raise it to the 5th power, we'll get 32 here. And we'll see that that is going to be 2. So inside our parentheses, we get 2, and then we have this cube on the outside. And again, this is because if we multiply 2 5 times, we'll get 32. So multiplying now this 2, so taking 2 cubed, we'll get 8 here. Alright, now we're going to switch gears a little bit to rewriting these radical expressions with rational exponents. So let's look at this one here. We have the 6th root of n to the 5th power. Well, remember, we can rewrite the nth root to the 1 over 6 power again, just by using the fact that these two are equivalent. Then when we know that we're going to multiply these exponents here, so we'll get n to the 5 over 6 power here. Similarly for this one, we'll rewrite this as 5y to the 1 over 5 here. And there's nothing further we can do with this one, so that'll be our final answer for that guy. Now for the next one here, we have to be a little careful. What we'll do here is look at what's happening on the outside of everything. We have this square root here, so that means everything under this radical symbol is being raised to the 1/2 power. So that's x times the 4th root of x to the 1/2 power. We also know that we can rewrite this here, the 4th root of x, as x to the 1/4 power. So this will be x times x to the 1/4 power to the 1/2 power here. All right, now on the inside here, this x is to the power 1 here, and this x is to the power 1 over 4. And when we multiply variables, what we do is we add their exponents. So this will be x to the power 1 plus 1 over 4 on the inside. Now to add these guys, we need to get a common denominator. So this would be x to the power 4 over 4 plus 1 over 4. So we'd get x to the power 5 over 4 to the 1/2. And then in this case, we're going to multiply these exponents. So 5 over 4 times 1/2 is going to be x to the power 5 over 8. All right. And the last thing we're going to do is find the domain of root functions. And so going back to the top really quickly, remember this here. If we have that our exponent is odd, the domain is going to be all real numbers, and if it's even, it has to be all non-negative real numbers. So looking at these functions here, we first want to find the domain of this guy. Now we're looking at the square root here, so that means this power here, n is equal to 2, and this guy is even. So this tells us that this guy under our square root has to be greater than or equal to 0. So the reason why is because, like we said, when n is even here, we're looking at the square root or the 4th root and so on. And whenever we multiply to negative numbers, we get a positive number. So when we take an even nth root of something, we're never going to get a negative number. So our domain is just going to be all positive real numbers. So this tells us that 4x has to be greater than or equal to negative 12, so just subtracting 12 on both sides. And then dividing by 4, we get that x needs to be greater than or equal to negative 3. And so our domain is going to be from negative 3 up to infinity here. All right. Now in this case, for part B here, we have this minus sign out front, but we're still looking at the square root here. So this n is equal to 2 here, and it's still even. So in this case, we also need that whatever's under the square root to be positive. We can't take the square root of a negative number. So this tells us 3 minus x needs to be greater than or equal to 0. We can take the square root of 0. That's fine. So then we'll get x is going to be less than or equal to 3. So our domain is going to be negative infinity up to positive 3 here. And the last one we'll look at here is this function. We want to find the domain of this guy. And in this case, our root here is 5. This guy is odd. So this means our domain is just going to be all real numbers. So negative infinity up to positive infinity. Alright, so now we're going to look at several examples of solving an equation involving a root function using the properties of power and root functions that we just saw. So here's the four-step process for doing so. The first thing we want to do is isolate the term involving a root to one side of the equation. Then we'll raise both sides of the equation to a power that will eliminate the radical or the rational exponent, and then solve the resulting equation. And if we still have a root present after this step here, then we'll repeat steps 1 and 2. And then lastly, we want to check each proposed solution in the original equation to make sure that it is in fact a solution. So we'll start with this example here. And notice we already have the term involving the root on one side of our equation, so step 1 is done for us. Now for step 2, we want to raise both sides of the equation to a power that will eliminate the radical or rational exponent. So notice that we have x minus 5 is equal to the square root of 6x minus 3. This is the same as 6x minus 3 raised to the 1/2 power. So if we raise both sides of our equation to the second power, or square both sides, these guys will cancel here. So then we have x minus 5 is equal to, x minus 5 squared is equal to 6x minus 3. Now, foiling this guy, we'll get x squared minus 10x plus 25, and then that'll be equal to the 6x minus 3 on the right-hand side. Now we can solve this like normal. First thing I'll do is subtract 6x on both sides. So we'll get x squared, and then we have minus 10x minus 6x, so that'll be minus 16x, plus 25 is equal to negative 3. Then we'll add 3 to both sides of this guy, and we'll get x squared minus 16x plus 28 is equal to 0. So now we can factor this. We just need two numbers that'll multiply to 28 and add it to negative 16. So that'll be negative 2 and negative 14. So this gives us that x is equal to 2 and x is equal to 14 are potential solutions. But for step 4, remember we need to check each proposed solution to make sure that they are solutions. So the first thing we'll check is the x equal 2. So we'll plug x is equal to 2 into our original equation. So we'll plug it into this guy here. So we have 2 minus 5 is equal to the square root of 6 times 2 minus 3. So we'll get negative 3 on the left-hand side. Then we get the square root of 12 minus 3 on the right-hand side. So that's negative 3 is equal to square root 9. So we'll get negative 3 is equal to 3. And we know that this is actually not true. Negative 3 is not equal to 3. So this means x is equal to 2 is not a solution. Alright, so we'll check 14 next. Again, plugging this into our equation. So we'll get 9 on the left-hand side is equal to the square root of 81. And square root of 81 is 9. So this tells us that x is equal to 14 is a solution. So our solution set will just be 14. Alright, so let's look at another example here. We have the square root of x minus 2 plus 4 is equal to x. The first thing we'll do is subtract 4 on both sides, because remember, we need to have the term with our radical here on one side of our equation. So we get x, the square root of x minus 2 is equal to x minus 4 here. Now we know that this is the square root here, and we know from the last example, we saw that if we square both sides, we'll get rid of that square root. So we'll get x minus 2 on the left-hand side is equal to x minus 4 squared. We can FOIL that guy, so we'll get x minus 2 is equal to x squared minus 8x plus 16. Alright, now what we'll do is we'll move everything over, so we'll subtract x on both sides. we get negative 2 is equal to x squared minus 9x plus 16. And then we want to add 2 on both sides, so we get 0 on the left-hand side. So we'll get 0 is equal to x squared minus 9x plus 18. Now we can factor this guy. We need two numbers that will multiply to be 18 and add to be negative 9. This will be negative 6 and negative 3. So our potential solutions are x is equal to 6 and x is equal to 3. All right, so now what we'll do is we'll check these potential solutions. We'll plug 6 into our original equation. So we get square root of 6 minus 2 plus 4 is equal to 6. This is the square root of 4 plus 4 is equal to 6. So we get 2 plus 4 is equal to 6. So x is equal to 6 is a solution. We'll do the same for x is equal to 3. We'll get the square root of 3 minus 2 plus 4 is equal to 3. 3 minus 2 is 1, so we'll get the square root of 1 plus 4 is equal to 3 here. Square root of 1 is just going to be 1, so we have 4 plus 1, that'll be 5, is equal to 3. But we know that that is not true. 5 is not equal to 3, so x is equal to 3 is not going to be a solution. So our solution set is just going to be 6 here. Alright, let's look at this next one here. We have the third root of 3x squared plus 9 is equal to the third root of 9 minus 4x. Now I know we have this third root here on both sides of our equation, and you might want to move that over first because we want our radical term to be on one side of our equation. But what we can do first is notice that this is the same thing as this guy to the 1/3 power, and this on the right hand side is the same thing as this guy to the 1/3 power. So if right off the bat, if we were to just multiply these guys by, or sorry, not multiply, but take these guys to the third power on both sides of our equation, these automatically cancel. And so then we're no longer dealing with these root terms, right? So if you ever have these roots on both sides of your equation and they're to the same power here, we can do that immediately. All right, now we'll solve like normal. So we'll subtract 9 on both sides. Doing so, those two will cancel. So we just get 3x squared is equal to negative 4x. Then adding 4x on both sides gives us 3x squared plus 4x is equal to 0. And then pulling out an x, we'll get x plus 4 here. Oh, sorry. We'll get 3x plus 4 here. So this tells us that x is equal to 0 and 3x plus 4 is equal to 0. So x is equal to negative 4/3. All right, now remember we want to check these guys. And we can, of course, check them by plugging them into the original equation. That's what we did for the past two examples. But in this case, it's going to be much easier to work with this guy. And we know that this is all equivalent. So this is we can work with plugging in our solution into this guy here. So checking x is equal to 0, we'll plug 0 into the simplified version that we got. So 0 times 3 times 0 plus 4 is equal to 0. We know that's going to be true because 0 times anything is 0. So we get 0 is equal to 0. So x is equal to 0 is a solution. We'll do the same thing with negative 4/3. We'll plug that into this guy here. We want that guy to be equal to 0. I'll move this over a little bit. All right, So we have negative 4/3 on the outside still. Then on the inside, we have 3 times negative 4/3 over 3. So these 3's cancel, and we're left with negative 4 plus 4 on the inside. This is going to be negative 4/3 times 0, and this will be equal to 0 because anything times 0 is 0. So that guy works, and so our solution set will be both of these guys, 0 and negative 4/3. Alright, now the last example we'll look at is one where we're working with negative exponents here. So in this case, we have x to the negative 2 plus 6x to the negative 1 plus 5 is equal to 0. Remember that when we have these negative exponents, we can rewrite these as this here. So writing these as positive exponents brings them into the denominator here. We actually don't need a 1 on that guy. So we can rewrite our equation as this here. Notice that the least common denominator for these guys here is going to be x squared, because we can multiply this by x over x to get x squared, and this guy by x squared over x squared to get x squared. So multiplying that one by that, and 5 is the same as 5 over 1, so we'll multiply this guy by x squared over x squared. So this will be equal to 0. Doing so, we'll get 1 over x squared plus 6x over x squared plus 5x squared over x squared is equal to 0. Now the reason we want to do that is because we multiply both sides of our equation by the least common denominator x squared, we get rid of the fractions here. So this x squared is being multiplied to every single term on this side, and this x squared is being multiplied to 0 on this side. So these cancel, and we'll get 1 plus 6x plus 5x squared is equal to 0 here. Now this is much easier to work with. We can just factor this guy. Factoring this, we'll get 5x plus 1 times x plus 1. So this tells us that 5x plus 1 is equal to 0, and we'll get that x is equal to negative 1 here. So this tells us we'll get x is equal to negative 1 over 5. And lastly, we just want to check this. So first looking at x is equal to negative 1/5. In this case, we'll again plug our values that we got for x into this simplified version here. We can plug it into this one, but working with this is going to be better than working with our original equation or anything with fractions here. So we have 1 plus 6 times negative 1/5 here, plus 5 times negative 1/5 squared. And that needs to be equal to 0. Move this over again. Alright, so we get 1 plus negative 6 over 5 plus 5 over 25 here. Dividing by 5 on the top and bottom of this guy will give us 1 over 5. So we have 1 minus 6 over 5 plus 1 over 5 is equal to 0. So we get 1, and we have minus 6 over 5 plus 1 over 5. So this will be minus 5 over 5, which is the same thing as 1. So we get 1 minus 1, which is equal to 0. So negative 1/5 is a solution. And doing the same thing for negative 1 here, we'll get 1 plus 6 times negative 1 plus 5 times negative 1 squared. So we'll get 1 minus 6 plus 5 is equal to 0. So we get minus 6 plus 6, so 0 is equal to 0. So this tells us our solution set is going to be both of these guys, negative 1 and negative 1/5. Alright, so that'll be it for this video.